So first, we'll talk about some data set descriptions and access. So in terms of just gaining access to data through NYC Open Data, there's very helpful tools like you have the Socrata API here, which allows you to essentially just extract data straight from their databases. So it's a very useful tool in terms of being accessible to everyone. I'm sure Izzy, you would want to expand on that a bit.
Sure, yeah. So for those, the developers on the team, I think, setting up API keys is, something that we kind of, it's accessible to us, but there are also other ways to access this data and actually query it from a UI. So for the 311 data, they actually have a dashboard where you can kind of filter out different times, different agencies and so forth, and essentially click a button to download that in, an Excel format, CSV format. So there are also other ways of accessing this data besides the API. So I'm not sure if maybe it's all good. We can take a moment at the end to kind of just walk through both of those databases and getting access to that data.
All right. So essentially, one of the key data sets that we decided to use that was publicly available to us was the 311 data sets from NYC Open Data. So you might be wondering why we decided to use this data set. Well, essentially, let's kind of just talk about what does 311, what is the purpose of it? So 311 in general serves the public, handles requests for government and non-emergency services, connecting residents, business owners, and visitors with information and people who can help them resolve whatever their issue or service that they need is. And so why 311 Open Data? Essentially, we thought this would be a great data set to analyze because it essentially 311 helps the public access services and information that they need. And this is basically sounds like a very good data set to try and glean insights from in terms of learning about potential issues that have been evolving, especially going into the pandemic year of 2020. And so essentially there were two 311 data sets that we looked at. There was the 311 call center data, and then there was the 311 service request data. Both of these data sets were they were similar in some ways in terms of basically they were New Yorkers kind of raising an issue of some sort or needing some kind of resource or service. But essentially the call center data set it looks like it just contains like all the information on agent handled calls to the city's 311 information line. And while the 311 service request data set kind of focuses on various services that New Yorkers need. So it's more focused on specific services as opposed to just kind of logging most of the calls and having just a general description about what it is they're calling about. And then I guess just also a note and something that we kind of considered in our analysis is that the data sets in the disclaimer on the website do not contain the full picture of 311 calls or service requests, basically because of everything going on with COVID and just the unprecedented volume that they're currently experiencing. So the 311 call center data. So the 311 call center data is a massive data set. There's 83.4 million records in total. There's 9 columns, and there's some pretty interesting fields here that to take a look at. There's the date, which is, I guess, a little self-explanatory in terms of the date that the call was made, but there's also inquiry name, which is the topic the call center representative uses to resolve the customer's inquiry. And then there's also the brief description, which is basically just a little bit more.
Sure. So I'm sorry to Trevor. So we have a question from someone actually. So I think, if it's okay, I'd love to answer that. So the question for everyone to kind of know, it says, why do you call this a data science approach and not an open data approach? So there's a few different reasons. So I think one, open data is wonderful. So it is available for both industry and non-industry industry, depending on the license that it has, for analysis. That being said, depending on what you work on, so if you are using more traditional statistical methods, or if you are working on some deep learning methods, the variability in missingness may not affect the model as much. So when I think about a data-driven approach, I think about trying to understand, is there a data catalog? Is there someone that we can email? This data set in particular was very interesting because they had 3 fields that ultimately were completely empty during 2020. And I had tried to search if maybe there was a law that might have happened where agencies no longer had to say when they responded to something. You kind of saw like a huge difference in that data. So I'm really excited to kind of discuss this. I think an open data approach, I would hope all data scientists are always searching for open data, but what really kind of makes this a data-driven approach is because we are thinking about what types of models we can build from it, as well as what type of insight, and also thinking about ways that we can either heuristically or find out how to evaluate the quality of this data. I hope that answers your question. Stephanie, I'm not sure if you'd like to say something or... Sure. So as you can see here, while most other civic services and so forth have seen a huge jump, we actually see less and less. So there's a huge decline in 311 call center logs. So they have already kind of disclaimed this, but it's very, very different from the other data sets that we have looked at. So that being said, I think that missingness can indicate many different things. So I have done a lot of deep learning within the medical space. And, in some cases, when we think about wearables and other data, that might have been more indicative of, someone's well-being. Maybe they were too sick to wear something or to log in and respond to something. And I think you can think about this data. So you can think about, this as, okay, we might not have a way to truly do a lot of statistical tests, but hopefully we're going to think about how, us in the open data community and the data science and AI community can think about understanding how not logging, certain data, might impact or show the impact of COVID on a different scale.
So here we have the 311 service request data set as well. This one's, in terms of like the total number of records, it's a little bit smaller than what we previously had. Some interesting fields in this data set are the date it was created, the complaint type, which is basically identifies the topic of the incident or the condition. And then there's also just like the brief description, which kind of gives you further detail about that. And then also what's interesting is there's the agency field, which is also kind of, it basically each service request, a lot of them are assigned with a specific agency. So it kind of gives you insight as well into the types of themes or issues that people are raising issues about. So these are kind of a lot of the fields, just a high level, so you can see all the fields that you have. It's very descriptive in terms of location, the agency, like we mentioned, the complaint type, the descriptor, and even like the city as well.
Yeah, and actually there are 41 columns in that data. So if we could, I'm not sure if we shared the slide for the call center data, but there are only 8 columns there. So this one has many. And here, this is just showing the missingness within the data. So, for us, we were really interested in looking at a few different variables in terms of looking at visualization, but we also wanted to share, how important it is to kind of just understand the missingness and possibly, what the reason was. for it. So with some of the other data sets that I've worked on with the government, something like NA or missing, they might actually have a reason for why that is, versus something like 999, which is a common, it might be a common indicator for missing data as well. So it's always important to think about these things. So here I had just decided to plot all of the latitude and longitude for 2019 service requests. And, you can actually go to the next slide if you'd like to. Essentially, it looks very, very similar. So from 2020 to 2019, it is something that is, interactive. I can send it out to anyone else who's interested in kind of zooming into the streets. That was kind of interesting in terms of a visualization approach. This was something new for me, and we also have one more visualization that we'd like to share that also, so for this one, I'm not sure if I can actually control your screen, but if you want to dive into basically where it has that huge red mark. So in 2020, we saw a huge, looking at the data, there was a huge uptick in noise complaints, and in particular in this block. So it accounted for almost half of NYPD's service requests within 2020. So right within this radius. And I thought that was very interesting. So another thing that I decided to do was really, think about the data sets that we had and how can we actually see if it can provide information about I essentially did, a causal impact analysis. So this is where you kind of think about an upcoming date and you basically, train a model to predict for that. As you can see, the model here in blue, that's kind of what it predicted. And March 15th is that line that I have there. So, based off of this, I think this is very, very interesting. So a lot of people have done this analysis with lots of different data. So things like hospital mortality and so forth. But even with just the amount of 311 calls, even, essentially, I haven't looked at all of like the confounding like factors that could be here, but what we see is that, we do see that it has the causal impact. So I forgot to add the citation for the paper from this, so I'll make sure to send that out. But I think that is very fascinating. So, and that is just from the influx of 311 service requests. And here is kind of just, a full analysis on it. For those of you who are willing to read it, I just want to I wanted to lay this out here just to dive into the approach in general, and then also talk about the effect. And also give basically the confidence intervals. So essentially, what we see is that there was a positive effect observed during this intervention period that was statistically significant and unlikely to be due to random fluctuations. That being said, it should be noted that the question of whether this increase also bears substantive significance can only be answered by comparing the absolute effect to the original goal of the intervention. That being said, just using a Bayesian one-sided tail area probability, we can say that causal effect is shown.
Okay, so here we have the consumer complaints database, and you'll see that there's actually data here for all of the states. But of course, we're focusing on New York. So we filtered to New York, but not just that, but specifically New York City, so all 5 boroughs. And so we found 31,270 records after filtering for 2019 through 2021.
One thing I'd like to add here is that there are some states in white, and so there are some reasons for why some states actually don't share this type of data. So that's something that, you might want to think about when you're analyzing data. So we specifically chose New York City, and we did have a lot of records to kind of work with. So
Yes, and so yes, and just a overview if it wasn't clear before, essentially these are all complaints from my financial perspective that have been logged with the Consumer Financial Protection Bureau. Um, yeah, so that's pretty much that. So essentially the key fields that we focused on was the date it was received. There's a couple of different there's interesting fields here. There's the product, the subproduct, the issue, and the sub-issue, and we're going to dive into these more. And then there's also the consumer complaint narrative and tags. So these first few here, product, subproduct, issue, and sub-issue, they're all text fields. And essentially what we'll get into in a minute is essentially that combining all of these text fields, it gives us a pretty good idea of the theme of a given complaint. And then we also have the consumer complaint narrative, which we also is also a very interesting data set because it literally contains just the freehand complaint of what someone's filed a complaint about with the Consumer Financial Protection Bureau. And then there's also tags, which has tags. So certain complaints are tagged for special populations. So this would include senior citizens or veterans. These types of tags have been placed on these complaints.
And other things that are within that database are also the company. So for instance, the company in which the complaint was made against, and whether or not they responded, when they responded, and whether or not it was timely. So there are a lot of different data points. So what we see here, again, so this just shows, 2019, the amount of consumer complaints, and then also 2020. They do share a very similar trend, but it is still much higher, almost double.
Okay, so one thing we kind of looked at is maybe you could just consider it some initial EDA. It's just the top 20 companies that most of the Consumer Financial Protection Bureau complaints were with. So you'll see we have at the top here for 2019, TransUnion, Intermediate Holdings, Equifax, JP Morgan, Citibank, Capital One, Bank of America, etc. And then for 2020, JP Morgan, Citibank, TransUnion. So I would say in general, the top 20 companies that most complaints have filed against have not really changed significantly from 2019 to 2020. And the companies that are up here may simply just be because they are one of the more popular financial resources that the public would use.
And I think, so for us, that just shows exploratory data analysis. And I think that if we had more time to dive into this project, we'd really want to look at some of the outliers. So Trevor will kind of discuss more about some of the themes that he's seen, but the conversations have changed from the year before, although some of them are similar. There definitely are some interesting conversations, and there's a lot of free text that is available within that consumer complaint. So
okay, so the process for what we did with the Consumer Financial Protection Bureau data set, essentially what we wanted to do, like I mentioned before, is we wanted to find themes of the complaint, and we kind of wanted to partition the data set into various themes to understand what kind of financial issues are plaguing New Yorkers and how have these evolved from 2019 into 2020. So essentially, high level, we use the unsupervised learning method called k-means clustering, and just step by step what we did. Filtered the data using zip codes to only contain complaints from New York City. Then the text fields, that was basically the body of text that was used to perform this, which the product, the subproduct, issue, and sub-issue. And then what we did was we used the new the new text data was pre-processed using something called TF-IDF. I'm not sure how many people are familiar with that, but essentially it is a way to measure the weight of rare words across all documents in your corpus. It's a way to essentially embed your text data. And so the TF part represents your term frequency, which is just the number of times the word appears. And then you have your inverse document frequency, which is essentially the log of the number of documents divided by the number of documents containing the word. So essentially, it's a way to measure the weight of rare words across your document. And so you just multiply those two terms together and you get TF-IDF. And then, so after that, after pre-processing the data, the optimal cluster was chosen using what we call here the elbow curve. And essentially what happens is you test a number of clusters to find the optimal fit to your data for the k-means clustering algorithm. So essentially the k-means clustering algorithm, how it works is you initially choose some centroids, and then essentially what you do is you assign the closest data point to that centroid. And then you recalculate your center based on the values that are assigned to it. And you basically repeat this process until convergence. And so basically what you're trying to do is minimize the square distance from all of your centroids. And that is basically what produces your score. So the higher your score, the better performing, the better your model fits your data. But what you want to be careful of is you don't want to overfit your data because then it doesn't generalize well. There's massive issues when it comes to overfitting data. So essentially how you would interpret this curve is what you would do is you'd kind of look at a point where you kind of have like an elbow and you get like a diminishing return in performance based on the number of clusters. So essentially it's not worth increasing the complexity of your model and increasing the number of clusters you have for just a minimal gain in performance. So interpreting this graph, we interpreted it and saw that 6 was a pretty good clustering point to use. Yes, and then this is just, again, going into TF-IDF again, where TF is just a part that is the number of times the word appears in the document, and the IDF, the inverse document frequency, measures the weight of rare words across all your documents. And then this is simply the formula, you just multiply the two to get your embedding. And so after performing our analysis, we came across 6 clusters that seemed pretty interesting and rather distinct. The first cluster, cluster 0, seemed to revolve around issues related to various types of loans and related issues to that. And so these were basically the ones that the model predicted were of this cluster. Some of the samples of the fields that you would get would be like payday loan, title loan, managing your loan or lease, charge fees or interest you didn't expect, which is also related to loans, things like that. The next cluster, cluster 1, we essentially revolved around credit and fraud/incorrect information, which was kind of the theme. You'll see here, information belongs to someone else, reporting companies use your report improperly, things like that. The third cluster, cluster 2, started at 0 though, is essentially revolves around banking services and issues related to that. So checkings accounts, savings accounts, issues using your debit or ATM card, funds not handled or dispersed as instructed, things like that. Cluster 3, these were issues related specifically to debt. And so this was involved with debt correction, but I guess it also had some incorrect information that seemed to be populating in there as well. And then we have cluster 4. Cluster 4 was essentially issues around credit reporting companies. And you can kind of see like the anecdotes here that were extracted from the body. Problems with a company's investigation into an issue, things like that. And then the final cluster here, cluster 5, was focused around like credit card and prepaid card issues. So general purpose credit card, store credit card, trouble using your card, things like that. And so what we found was super interesting is that there seems to be a huge increase in cluster 1. And if you don't remember, cluster 1 is the issue regarding just credit and fraud / incorrect information. And so this spiked in 2020. And just like also just note that 2021 is low. We're only partway through the year, so we really can't effectively compare that to the total counts for 2019 versus or 2020. This was super interesting in terms of the amount of themes around credit and fraud / incorrect information that seemed to have skyrocketed during the pandemic. And so just plotting this over time, we saw with this theme of credit and fraud / incorrect information, the spike, well, also is high. It is around coming, just fluctuating in the 300 and the 400 counts. But over here in 2020, it kind of just starts off there, but it only just steadily increases and increases. And then it seems to skyrocket September onwards. So it'd be interesting to see maybe what kind of events occurred during that time to maybe get an insight into what kind of financial issues, or if there's like increased widespread fraud or something like that going on in the New York City area during that time. And so here, essentially, what we did was we had two sentences here, samples from two different clusters. One regarding around the theme of debt, which is debt collection, I don't know, attempts to collect debt, not owed debt, debt is not yours. And then this was around theme one, which was like the theme that shot up from 2019 to 2021 regarding credit repair, consumer reports, incorrect information, things like that. And so what you'll see is just looking at this heat map correlation, you'll see essentially the words in the vector that essentially make up the theme of how that word ended up getting classified in its specific cluster. And so this is just kind of interesting. You'll see here with sentence 2, high strong correlation with debt here. And then over here with sentence 1, you'll see interesting things like just like the theme of it being, the issues being around credit, being strongly correlated, and even things like the word repair, which is kind of interesting as well, just because it could kind of fit into the, or incorrect rather as well, kind of fit into that theme of incorrect information and fraud and things of that nature.
So I think before I kind of go into a deep dive into, some of the deep learning approaches of thinking about representing words, I'd love for you to go back to that last slide. So, there's something else that people usually do beforehand, which is called one-hot encoding. So essentially, this just looks at, for all of the sentences that you were comparing, what words are both in the same sentence. This, although it does, provide more emphasis on rare words, there's still the problem of needing the presence of a shared word. So what I'm going to talk about next is talking about representing words, sentences, paragraphs, documents as an entire entire vectors. What that allows for is, comparing and doing very, very interesting analogies. I also just want to kind of shout out to, there are some problems to embeddings because they are completely, I actually do have some supervised embeddings that I'll be going through, but they're mainly unsupervised and built on essentially the news, articles, everything that's out there. So you actually end up finding that embeddings have a lot of bias within them. So there was a great paper that came out that said, women is to housewife or so forth, and man is to engineer. So when we think about these unsupervised learning, we need to think about, who are writing these documents and so forth, especially because embeddings are often used for downstream approaches for deep learning. And there has been a lot of recent literature of how that could actually affect a lot of different outputs. So
before we move on, could I ask a question?
Sure.
So I was wondering, for the clustering models, how do you pull out what the theme is for each cluster. Like I know that in the slides you showed some examples of sentences, but is that like, I know that the data set is pretty large, so you can't read everything that's in a cluster. So how do you then determine what the theme of a cluster should be?
Sure. Should I take that one?
I'm happy to take that one. I do have an LSI approach. I don't know if I have the notebook up or if I added it in the slide. It's completely up to you, Trevor.
Well, in this specific example of determining the themes from using the k-means clustering technique and extracting those words, essentially what I did was I built the model on the optimal k-means model on the data and then predicted on that data set. And so essentially I had the cluster values that were associated with each record. So I'm not sure if you're familiar with pandas, but you can filter based on the cluster that you have. And then all I did was essentially just take the specific fields that were used to create the text that was embedded to kind of look through and kind of see what the interesting themes that were kind of perpetuating throughout the clusters. And in terms of the data size, once the data was filtered and things like that, there were only about 31,000 records in the Consumer Financial Protection Bureau New York City subset. So it wasn't too much that it was not manageable.
Thank you so much for that question. So here I'm going to talk about something called Starspace because I was thinking about, I really want this event to be accessible to everyone. And although I have access to, GPU through academia and so forth, not everyone does. So Starspace is an incredible toolkit where you can do things such as image embeddings, collaboration, collaborative filtering, ranking and so forth. And it is compiled and ready for CPU. So I did a couple different models with the consumer database. In particular, one of them, which is called kind of a tag space model, we kind of think about that for making embeddings related to Instagram. So how do you utilize the tags to create some way of kind of ranking the documents or the entities that you find or the tags that you find. You can go to the next slide if you'd like. So this is just one example of kind of what's provided within the consumer complaint database. So there's a couple different ways that you can submit your complaint. One of them is by web. The other one is through phone call. So unfortunately for those, for a lot of special populations that I was interested in looking into, so, groups such as the elderly or veterans, a lot of them, they actually didn't have a full complaint response because they had done it through phone. But, what you see here is that things like, all capital letters, all of that kind of stuff can actually be encoded in a model. So the next thing that I really want to dive into is something called tokenization. So a lot of people just kind of, look over tokenization, they think, all I have to do is split on the spaces, correct? But actually there's a lot of different really cool ways to encode and give your model more information. So here, I'm not sure it's me, but I'm having, let me see if my view, So on the left here is one of the complaints. So, this person is, how did I turn that paragraph into, how did I tokenize it? So I kind of follow 5 major rules. So a lot of people have different ones, but I like to start with a beginning of sentence. I also like to, make a mark if something has been repeated consistently, as well as if all capitals were used. So I think this example doesn't show that many, but I will be kind of walking through that corpus and the labels that I decided to choose to predict for. And hopefully that can give more context into thinking about tokenizing embeddings and what you can do with that. So this is actually one of the embeddings that I did was, so I did a couple. So some of them that were completely unsupervised. This one was just with 80% of the 2019 complaints. And so you see here for cosine, distance, if you look up the term bankruptcy, you can see terms like, modification, synchrony, companies maybe, and also digits. So another thing that I do normally do is replace digits with a placeholder. But for this in particular, I was actually kind of interested in later extracting, mentions of money and seeing what else could be done for that. That being said, I do recommend, if you are going to start making embeddings, which I hope that you will be if you don't already do so, that you probably think about replacing the digits, even though I didn't do that here. So here I just show, using named entity recognition on a complaint. So for this one, I love to use pre-trained models. So, if there is a model that's out there, I definitely recommend you utilizing it. So when we think about models like BERT, training something like that, takes the same amount of energy as a transatlantic flight. So, if there are open source models that have entities that you believe are useful for you to use, I definitely suggest using that before training your own. So here I used something from Spacey, and what was cool is that there were mentions of, laws, dates, companies, and so forth. You can see here that the dates are actually encoded. So I probably should have written a rule that replaces, if anything is tagged as org and it has, this pattern, ignore that. But you can imagine that this could be useful for kind of filtering the data, like who is actually talking about, what laws. And even though, the company or the outcome may have not been, maybe it ended up being not disputed, maybe it's worth taking a look at some of the laws that were extracted. So I think this is like an exciting way to kind of tag documents and think about information retrieval. Sure, so I'm not sure if I can share my screen. I know we're kind of at question time, but I did kind of want to share my screen really briefly, just to kind of show you an example of a supervised learning model that I had done, in particular with this data set. And, also for us to kind of think about, is this probably the best thing we should be predicting for? So I'm not sure if I have access. So here, so there was a question before about topic modeling. Something that you can do after TF-IDF is also latent semantic indexing. So here, I think what's interesting about the words that you find are, here you see theft, victim, identity, reporting, as well as some weights. That being said, I still think that, TF-IDF is absolutely the first thing to kind of go through. And LSI still has the same problem of really relying on words to be the same within to be present within the same sentence. Please let me know if you need more explanation. Like sometimes I will say jargon that's not really, maybe isn't very clear. So I am happy to kind of dive into that a little more. So is everyone able to kind of see my screen? I think that's, yes. Okay. All right. So here, I'd love to talk about, again, talking about tokenization. So here, this is something like beginning of sentence. Also, if something is unknown, I use this kind of token. If I'm using kind of medical NLP, I do a totally different approach. But for a financial, text mining, this is something that I'm a little bit more new to. So I decided to use this approach. So here you're just seeing that if something is repeated, you'll get a symbol. And then you'll also get symbols for repetition. I think I see the most, as well as all caps and other types of things. Here, I decided to pick, within this data frame, there's a lot of variables, but I decided to pick one that I find, maybe an easier task. That being said, it may not be the most useful one. So here it is predicting whether or not the company will actually respond based off of what you've written. So, here, most of the time you see things like non-public response, maybe the company saying considered lawful behavior, a lot of different things. So facts disputed, which means that the company does not believe that, they've actually disputed against that. So there's a lot of different things. There's 10 categories in particular. So, when we think about, what we're doing machine learning for, this is where I couldn't find out in the database, what is the true output? So even if a company disputes it, did they really break a law? That's very hard to understand. So themes that we saw especially were things with fraud, and so forth. So the next part of this project, unfortunately, it's still running on GPU, but it's how do you actually take the categorical information, so things like company, and make embeddings on those to subset, the free text information as well as the non-free text. So I hope that this makes y'all excited about NLP. I definitely will be writing up a more detailed tutorial, and we'll be putting all the code up on GitHub. Another thing I quickly wanted to share was just, here. And now that I think about it, it's not as like user friendly, but some of the models that we use have very, very interesting ways that they embed words. So you might have heard of these things called transformers. So they've kind of really changed they've really changed the game for NLP and deep learning. They're almost like ImageNet, but for NLP. So Elmo was first, and then it was BERT. This one that I'm showing is Roberta. And essentially there are these weird little symbols that are kind of in front of the word. And then for the end of the sentence, they use an encoding like this. So I really just kind of wanted to share that there's a lot of different ways to think about working with text data. And depending on what type of model you're using, that is incredibly important. So are there any questions? All right, so I'll stop sharing. I know staring at an IDE is not always great, but I really hope that you found this interesting. I would like to kind of go back to the slides so that we can kind of discuss designing, deep learning in general.
Can everyone see?
So one thing I kind of wanted to share about is just some more topics on NLP. So I talked about information and text extraction of organizations, persons, et cetera, within documents. One of the biggest threats that we're kind of seeing right now are kind of auto-generated text and disinformation. So when we think about laws like net neutrality, there was a lot of, chatbots that were essentially not real. So that's kind of a topic. And for me, I'm really interested in translation, especially, for, why do we do NLP? Really, it's to help people who, may not have access to a doctor and who can freely speak to them through whatever language they speak. Another thing that I want to talk about is just, also the importance of, having more women in deep learning. So recently there was a study that came out that looked at all of the AI journals, and there really are only 12% of women within AI. And so I want to just quickly differentiate between what I mean by AI and data science. So AI in particular, this is just thinking about deep learning. So working with a lot of multimodal data, which just means, free text, image data, possibly, video data, and so forth. So my hope today is that, if there are any women who are interested or are already in deep learning, like, I'd love to connect. Absolutely. Trevor, do you think you could share the next slide? So this was something that I just heard about recently, and it's called a drivetrain approach to AI. So we always hear a data-driven approach. And this was something that I found very interesting, and I kind of wanted to close out this session with some of the things that I've learned about reading about this in particular. So there's a couple centers that have kind of put together things to think about when you're building AI. So one, should we even be doing this? What bias is in the data? Can the code be audited? What are the error rates for the different subgroups? So I decided to predict on, whether or not the company would actually respond or provide some financial, output or so forth. But should that really be, what I'm predicting for? That really needs me speaking to stakeholders and kind of thinking through the question. So also thinking about what is the accuracy of, a simple rule-based alternative. And then what processes are in place to handle appeals or mistakes. So when we're doing deep learning, I think about it a lot in medicine, is that there's a lot of opportunity. But at the same time, who takes the risk? We haven't really established that, I think, anywhere. So I think that that's, something that I really think government will probably play a huge part of, data scientists who may be mining through policies. And then also thinking about how diverse is the team that actually built the data set. Additionally, the Makula Center, they've also kind of given this approach of, thinking about who will be directly affected by this project, who will be indirectly affected. So right now you see a lot of automatic things to look at resumes or to judge like the quality of some sort of paper or so forth, or grant prediction. But you also see things like, loan prediction, lots of different things. So it's very, very important for us to be thinking about this problem. I think deep learning in particular, we decide to create something, we put something on GitHub, and then we actually don't think about how it may be deployed later. We're just excited to share it. So what, will the effects, in the aggregate, like, will it likely be more good than harm? And what types of good and harm? Are we thinking about all of the relevant types of harm and benefit? So this can be anything psychological, political, environmental, moral, cognitive, emotional, and so forth. And how might future generations be affected by this project? So I think about this a lot. I was very fortunate to get so same with Trevor, we've gotten, scholarships from the NIH and DeepMind, but right now we see that, younger people of color are actually, at risk for suicide and so forth, and they're given less opportunities and access to things like scholarships. So that's very important to think about. So have we adequately considered dual use and unintended downstream effects? The alternative lens to this could be a deontological perspective, which focuses on the basic concepts of right and wrongdoing. So what rights of others and duties to others must we respect? How might the dignity and autonomy of each stakeholder be impacted by this project? And what considerations of trust and that of justice are relevant to the design of this project? And does this project involve any conflicting moral duties to others or conflicting stakeholder rights? And how can we prioritize these? I don't have the answer to any of this. This is something that I'm just learning about, but I really wanted to kind of open this up for anyone who had ideas, especially for those who are working in making open data accessible, civic people. For me on the deep learning side, I'm very curious as to what's going on in that space. So, and Trevor, I'm sure you'd like to add anything as well.
Yes, we also have a question in the chat. I see. What resources do you recommend to learn more about NLP?
Sure. So I have a huge list that I can provide for you about learning about NLP. In particular, I'll definitely send that over. A lot of open source tools. I also have a Quora blog, so I talk about that a lot. Where I kind of provide resources. So I think that if you have access to, I think there's some good Medium blogs. I think for me, I've been really fortunate to kind of get mentorship from Kung-En Cho, who's very pivotal and kind of the AI stage. That being said, I also want to say that even though we do a lot of math, I promise that even if math is not your strong point, you can definitely get involved in NLP and it will come back to you, and definitely reach out. So I think at the end of this, we did provide our email addresses, but I'll go ahead and I guess I'll provide that, or I'll provide my LinkedIn.
Same as well.
So we have about 10 minutes left, and I would love to hear from the room. So I mentioned encoding for Roberta. That was with the G symbols. And then BERT, it kind of uses one that has brackets around it. I'm looking at some of the questions. Yeah, they all have kind of funny names. Elmo, BERT, Roberta, GPL. I guess in terms of NYC Open Data Week, I think that I'll kind of reach out to them and see, what's the best way to share with all of you any resources. We're also really open to feedback, anything that you found that was not helpful or confusing, as well as things that you thought were helpful. Sure. So I just got another question about the Starspace concept. So if it's okay, I'd like to just kind of share my screen because they do a better job than I will about explaining it. So Starspace is really cool. It's super efficient. It is a general purpose neural model. So it is a deep learning network. And you can use it for a bunch of different tasks. So you can use it for learning word embeddings, sentence level embeddings, document level embeddings for downstream tasks. You can also use it for information retrieval ranking. So sets of entities. For me, I'm mining Instagram. I want to know what's up. I kind of use it like for tags. And then text classification just for what I talked about before. So is this complaint, what's the response for that? And then looking at similarities. So looking at, how similar are two documents, and then also collaborative based filtering. So this can be anything from recommending music or videos. The way that you have to set that up is a little bit more complicated, and you do need to kind of have a matrix where where you have shared information about what people have both read or watched. And then also you can do embedding graphs. So Freebase was something where they had, a person and you had a link in between and, maybe some sort of relationship to a job or a business and so forth. So you can also make embedding graphs. And then you can also use it for image classification ranking, a whole bunch of things. What's really great about this is that if you don't have access to GPU, I mean, I do suggest like probably, I have a Mac, and I can kind of give the specs, but I can kind of share how long certain things take. But for some of the models that I've built for this task, they've been actually really, really efficient. So it's built for that. So here's an example of using tag space embedding. So you have an input file format, and you basically use the tag as a way to label the data. So I definitely recommend checking this out. They have a great paper where they compare their methods to a lot of, more computationally expensive tasks. And also, this can be used for learning sentence and article embedding. So maybe you have a sentence in mind and, what you'll get back is like an entire article about it. So that's super exciting. That example, if you do want to train, will probably take quite a few days, but it is really cool. And then lastly, the image embeddings and so forth. And here, again, so querying nearest neighbors, this is just looking at, cosine similarity and so forth. You can, say the number of nearest neighbors. So, maybe you want to look at the 10 most similar sentences or words. That's very, very important, as well as looking at the sentence and document embeddings. I know that we're kind of at time or close to time, so I really want to give anyone the opportunity. I know that we have 3 more questions. So thank you so much, Trevor.
Yeah.
I was going to provide a demo, but I don't think we have enough time, but I'll make sure that I put document up and, put that model up so that anyone can kind of use it. So I guess I did say that we would talk about our key findings. So one thing that we did find is that I would probably do more statistical analysis, but 311 calls actually do show causal impact for, that March 15th date. And then also there is, a statistical significance in terms of, people complaining about fraud, identity theft, and so forth. Anyways, I think that we're kind of at the end. I just was really excited to do this. I remember last year going to a lot of the NYC Open Data Week events and it being in person. And I really just want to thank the organizers for doing this and really working with us to be able to put on this event. I can't imagine. I think it's so exciting that you've got so many events. So I'm really, really excited about that.
And thank you all to everyone that joined this Zoom event. Really appreciate it, guys.
Thanks, everyone.